The biggest thing here is making sure that our limits are here the entire time. We cannot abandon our limits. Make sure we write that through the entire time. Everybody, welcome here to Cranky Calculus. We're going to work on some trickier LHOP problems. Do not forget to like and subscribe. And also, this worksheet here, this set of notes, is in the description. It's for free. What are you waiting for? Get this stuff, get this free stuff. Also, like, subscribe, more free stuff, more free content for you. This is to help you out learn some calculus. So within that, let's go ahead and do some of these trickier LHOP problems. All right, let's get to this first one. So for these, we're going to have some issues with some of these LHOPs. We're not in the form of 0 over 0 or infinity over infinity, but our goal here is to rewrite it to get it into those ratios. So if we look at our very first problem here, we have a 0 times an ln of x. Sorry, not a 0, an x times ln of x. Don't know why I said 0. I was plugging in my head already. So we know that x is 0 as limit as x approaches 0. So that substitutes into the 0 right away. But if we substitute in for the purple here, in case you don't know what ln of x looks like, it looks like this graph right here with a vertical asymptote right on the y-axis. So as we approach 0 to the right, we're going to get to negative infinity. So we're going to get to the form of 0 times infinity or negative infinity. So we need to rewrite this as a ratio so that I can go ahead and use LHOP. So what I'm going to do is I'm going to take my linear form. It's easiest to rewrite my linear and rewrite that as ln of x all over x to the negative 1. I can rewrite x as 1 over x to the negative 1. That's totally legal. Now I can use LHOP because you're going to notice that my numerator and my denominator are both going to go to some form of infinity here. So as I'm looking at 0 to the right of ln of x, I'm actually going to go to negative infinity. And if I'm looking at x to the negative 1, by the way, x to the negative 1 is the same thing as 1 over x. Looks like this. So this is going to go to positive infinity. So I can rewrite this using LHOP as the limit as x approaches 0 to the right. The derivative of ln of x is going to be 1 over x all over the derivative of x to the negative 1 is going to be negative 1 over x squared. Okay, so now I can rewrite this again. So this becomes, I'm going to actually find the reciprocal of both of those and actually make that into the negative x squared on top over x. And now my x's cancel out. I actually just get the limit as x approaches 0 from the right of a negative x. And if I plug in a 0, I'm actually going to get an answer of 0. So this one is going to equal 0. Moving on over to our next problem here. This is going to be one where if I'm plugging in the 1 to the right, I'm going to spare the graphical details here, but we're going to be in the form of infinity minus infinity. Or some sorts of infinities minus infinities. So what we're going to do here is we are going to rewrite these ratios. So I'm going to multiply this by ln of x over here so that I can get the numerator and denominator to equal each other. And over here I'm going to do, whoa, don't know what happened there, x minus 1 times x minus 1. So I'm going to multiply these here and here so that I can just get one ratio. So I'm going to end up with the limit as x approaches 1 to the right of x minus 1 minus ln of x all over ln of x, x minus 1. Okay, so here's my brand new ratio when I do all this multiplying. And if you notice, we are going to be in the form of 0 over 0. That numerator is going to equal, as we plug in 1 to the right, that numerator is going to equal 0. Because ln of 1, don't forget, is 0. So I'm going to get 1 minus 1 minus 0, which is 0. And that denominator here is going to be ln of x, x minus 1, which is going to be 0 times 0. So now I can LHOP this one. So when I do that, I'm going to get the limit. Don't forget to write down your limit statements. Like, holy cow, what a mistake that can be on these. Write down your limit statement. Just do everything right. It's not that hard. Just do everything right. Come on. And then the derivative at the top here is going to be 1 minus 1 over x all over. Product rule. It's going to be 1 over x minus 1 plus ln of x. Okay? Every time I zoom in, that kind of goes away. That's really annoying. So, can I plug in a 1 as is now? I don't think I can. What I will do, though, is I will clean this up a bit. I'm going to multiply every single term by an x here. I'm going to show that in red. I'm going to multiply every term by x because I think it's going to clean up some of our mess that we have here. So it's going to rewrite this now as the limit as x approaches 1 to the right of x minus 1. I'll do some cleaning up there, and then x minus 1 plus x ln x. Looks like we're going to have another L hop going on here, because if I substitute in a 1, I'm going to end up with a 0 over 0 again. So I'm going to show that right up here, if you do not mind. Like I care if you mind. Of x approaches 1 to the right of x minus 1 plus x ln of x. I'm going to have another product rule as I do this one. So for 1 to the right, I'm just going to get 1 on top, which is nice because now I'm done doing L hop because the top is 1. I'm not going to have any issues here. Bottom here is going to be 1 plus, looks like I'm going to get ln of x plus x times 1 over x. And I can plug in a 1 now. We're going to get a nice number here. We're going to get 1 over 1 plus 0 plus 1. So we're going to get a nice answer here of 1/2. On to this last problem we have here. Again, reminding you, like and subscribe. I don't know what you're waiting for. It's really annoying. Knock it off. Like and subscribe. Make it happen. Last problem here. This is one of the more complex ones. If we ever need to rewrite anything, because we're in the form of 0 to the 0, infinity to the 0, 1 to the infinity. All my students are like, 1 to the infinity. That's just 1, because that's just 1 times 1 times 1 times 1. Well, not really. And actually, I think this is an example we're going to have that's 1 to the infinity. Because if you look at this next example right here, if you are to just substitute in that 0, I know you can't substitute the 0 in for the cotangent of x, but if we plug in a 0 to the right of the cotangent of x, that does give us an infinite. So this is a form of 1 to the infinity. So what we're going to do here is, in order to solve for this, I'm going to call this answer, I'll do this in gray. No, I'll do it in pink. I feel like there's going to be better colors than this. I'll do it in purple. All right, let's just call this answer y. All right, the answer's y. We're done. We'll walk away, people. Nah, I'm just kidding. What you're going to do here is you're going to use some ln properties. So we're going to use some logs here. We're going to use the ln on both sides. The whole reason we're going to do that is I want to get that exponent that's up there, that cotangent, and we want to bring it on down. So I'm going to find ln of both sides. So I'm going to do the limit as x approaches 0 to the right. ln of 1 plus sine 2x. Cotangent of x equals ln of y. I'm going to let that ln of y just go down with the entire problem, and I'm going to use that at the very, very end, so don't worry about that. So now I'm going to rewrite this cotangent, so I'm going to get limit as x approaches 0 to the right. I'm going to go to cotangent right up front right here, times ln of 1 plus sine 2x equals ln of y. Again, that ln of y is just going to carry on through. My answer is y. I will solve for y here momentarily. I want to make this into a ratio so that I can use L hop. So I'm going to make that cotangent into a tangent by finding its reciprocal here. So I'm going to have ln of 1 plus sine 2x in the numerator, and then tangent of x in the denominator. Ooh, this looks like a fun one. So you can clearly tell that I need to use L hop here, because if you look at the limit of the numerator, we're going to end up with ln of 1, which is 0. And if you look at the denominator, hopefully you know what tangent of 0 is. If you don't, luckily I do. It's going to be 0. I can go ahead and use L hop, so I'm going to just note that right up here. So LHOP it. So we're going to do LHOP. And this is going to be the derivative of the ln. Oh, this is annoying because I got some chain rule within chain rule. Oh, wait, let me write the limit statement. Ugh, I was almost one of those people. Limit as x approaches 0 to the right. And then I'm going to actually have a ratio right here. The bottom is going to be 1 plus sine 2x. And the numerator is going to be 2 cosine 2x. I think this is going to be nice. Derivative of tangent of x is going to be secant squared x equals ln of y. All right, we can plug in 0 now. We're going to be fine. When we do that, I'm going to get 2 times cosine of 2 times 0, which is cosine of 0. Cosine of 0 is 1. So I'm going to get 2 over 1 all over 1, because secant squared of 0 is just 1. Squared is just 1. And this is going to equal ln of y. So I'm going to get 2 equals ln of y, which means that I have my y answer now. Y is going to equal e squared. So this limit right here is equal to e squared. That is totally insane. So these were some trickier problems here. The biggest thing here is making sure that our limits are here the entire time. We cannot abandon our limits. Make sure we write that through the entire time. But we had some good fun with this one. Make sure that you like and subscribe for more content. Thank you so much for watching. It is appreciated.